I feel you.
Yeah,
Are you trying to ace it?
I wanted to, but I don't know. There's too much. It's just too much to cover. You
Mm,
know, I'm used to having tutors, and this semester there aren't. I wasn't able to have that anymore.
yeah.
For for a class like this, I typically need like tutors. There was a few, but I
Okay.
wasn't able to have this advantage like I've had in the past.
Yeah.
So
Okay.
I,
So
mhm.
what are you doing? Just graphing trig functions or what?
I actually figured that out. I'm pretty good with graph and trig functions now.
Okay.
But this part right here on the pic where they want us to find the values of x, I have no idea how to do that. Like I'm just lost on
Oh,
that
you
one.
mean like right here on the right here it says find all the values of x that satisfy this equation? This?
Yeah, yeah, those.
Okay. Got it. Okay, so let's try it. So it's
All right.
between 0 and 2 pi, right? We need to find all the values of x between 0 and 2 pi that satisfy these equations.
Yeah,
So let's see. What we can do,
I have a unit circle. Does that help?
yeah, if you have a unit circle, that can work.
Okay.
Yeah, the unit circle, I mean, one thing you can know is a triangle too. You can get used to a triangle
Mm-hmm.
and say, if you memorize like the fact that on a triangle, like on a 30, 60, 90, because these
Yeah,
numbers, 1/2 and √3/2, these are like common numbers that we know already. One
yeah,
half, 1/2 and √3/2. So the opposite side of 30, actually this would be 30 because this angle is the smallest. So this side is like the smallest down here. So that's 1. What was this? This is like 2 and then like √3. Does this look familiar?
yeah. It does.
This sort of triangle. So we know that cosine is, well, actually, remember there's a thing called SOHCAHTOA.
Yeah, yeah. So
SOHCAHTOA. So we're talking about cosine right now. So we want to
yeah.
know where. So that's adjacent over a hypotenuse, right?
Mm-hmm.
Cosine is adjacent over a hypotenuse. So we're talking about where would where would it be? Like notice at this angle right here, 30 degrees. The
Mm-hmm.
adjacent, what's the adjacent?
The adjacent would be √3.
Okay. So then it's not 30. What about this one? What's the adjacent of 60?
The adjacent would be 1.
Right. And then the hypotenuse is 2. So we know that it's 60 degrees. And in fact, we should in fact since we're dealing with radians, I just realized we're dealing with radians. Are you familiar with radians?
A little bit, yeah.
So this is like what, 30 degrees. 30 degrees, what's 30 degrees in radians? Do you know?
Not
Pi over
off
6.
5 or 6, yeah.
Yeah, so from the circle of trig, yeah, since you have the circle of trig, you're allowed to kind of, well, that's an ellipse. Hold on, let me draw a circle. A circle drawing skills are kind of weak right now, but let's see. If you have the circle of trig, then, oops, I should have drawn that straighter. Another thing to think about from the circle of trig is that it's kind of a good way to do it too. If you break this up into thirds, well, actually, I could have drawn this all the way here. Notice how you can break the circle into thirds and say that this is, so you got to get good at radians. So this is pi over 6. What's this? Pi over 3. This is pi over 2. Are you familiar with that?
Yeah.
Pi over 6, pi over 3, pi over 2.
Mm-hmm.
Yeah. So then we know at this point, if I draw another line like right here,
Mm-hmm.
then another line right here. Those are like the pi over 6 lines. If I count by pi over 6, then that's kind of like the lines. Notice that there are 12 different slices of pizza here. 12, right? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. There's 12 different slices of pizza because you're dividing it in pi over 6s.
Yeah.
So that's just, don't worry too much about that. But we know that the adjacent of pi over 3 is 1/2. So, okay. A lot of ideas come in here. Now, question at hand is where does cosine of x equal to negative 1/2? That's what we're trying to figure out. Where does cosine equal negative 1/2, right?
Yeah.
Now, notice that cosine is kind of like x. Cosine is like x. Did you know that? Because when you look at the ordered pairs,
yeah,
it's cosine, and then sine. Cosine is like the x value, and sine is like the y value. Did you know that?
no, I didn't know that.
Yeah. So now when because I understand that when I look at this equation, I see that it's equal to a negative value. I see that cosine is equal to a negative value. Do you see that?
Yeah.
Now cosine is like x though. So that means the x values are what? Negative. So we are on this side. You understand what I'm saying?
Oh,
We are
yeah.
on this side. And we know that we're here. We know that we're here. Oops, that was the eraser. We know that we are here, 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 and here. We're sort of here on this level because we're at the reference angle of 60 degrees. We're at a reference angle of 60 degrees. Why are we at a reference angle? Because remember how I was telling you earlier right here? Pi over 3 was 60 degrees. It's the bigger angle because it's 1/2. So we know that we're here, 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 and here. So between 0 and 2 pi, we know that cosine is equal to a 1/2 here and here and negative a 1/2 here and here. So these are the 4 locations that cosine equals to a 1/2. Absolute value a 1/2. It's positive on this side and negative on this side.
Yeah.
So there's 4 locations where cosine equals to a 1/2. Guess what? Cosine equals to a 1/2 down here. Cosine equals to √3/2 down here and down here. Because that's the 30-degree reference angle. So there's 4 locations that cosine equals to √3/2. Here, 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 and here. And it's positive on the right and negative on the left. Because cosine is like x, and x is positive to the right and negative to the left.
Yeah.
So the answer that we're looking for, our answers, are these values here. Now, this is 1 pi over 3. This is 2 pi over 3. This is 3 pi over 3. This is 4 pi over 3. This is 5 pi over 3. I'm counting by pi over 3s. There's a way to count by pi over 3s. If I count 1, 2, 3, 4, 5, and 6. There's a lot to learn about trig, you know?
Yeah.
There's different ways to count around the circle. And if you know how to count around a circle, that can help you a lot.
Yeah.
So cosine equals to a 1/2 to negative a 1/2. What would the answer be? Where does cosine x equal negative a 1/2?
Let's see.
Remember, I was telling you that this value. value and this value are the values where cosine equals a half.
Yeah.
By the way, these
Yeah.
three values that I just highlighted, they
Yeah.
all have a reference angle of 60 degrees. They all have a reference angle of 60 degrees. In other words, the angle from the x-axis, oops, I'm using a highlighter. The angle from the x-axis to the line is 60 degrees or pi over 3. So from here to here is pi over 3. From here to here, it's pi over 3. From here to here is pi over 3. All of those blue lines, they all have a reference angle of pi over 3. That's why all of them, the cosine equals to a half.
All of them.
So cosine equals to negative a half. The answer is going to be, we could say x equals to 2 pi over 3 and what? 4 pi over 3.
And 4 pi over 3.
2 pi over 3 and 4 pi over 3 would be the answer.
Wow.
I can do more examples because that's I mean I taught a lot there. Or this is like my first time helping you out, and I'm teaching you all of trig in like 5 minutes.
Yeah.
I taught you about reference angles. I taught you about triangles, the circle of trig, how to count on the circle of trig. What I
Yeah.
taught you is like, I don't know, like an hour's worth of kind of knowledge within 5 minutes. So that's kind of hard for you to take in because I don't know what you know. I don't know what your teacher teaches you. You know what I mean?
Yeah.
Another thing that you can do is plug this in your calculator like this. Watch. See if on my thing is frozen. So if I say, so I have cosine x equals to negative 1/2, right?
Yeah.
If I take cosine inverse of both sides, I get x equals cosine inverse of negative 1/2. So I can plug that into my calculator and get something like, let's see what my calculator tells me. It may not be a good idea because I don't know. Let's see, cosine negative 0.5. Because that's giving me, yeah, 2 pi over 3 is a rational number. Or sorry, irrational. So it's not going to give me a nice value unless my calculator is not giving me any pi's. So yeah, that's not a good idea. But notice that 2 times pi divided by 3 equals 2 that. Do you see that?
Yeah.
So that is the answer because cosine inverse of negative 1/2, I just plugged it in my calculator and I got 2.093495102. And that's the same thing as 2 pi over 3.
Oh. So you just, okay. So if it's cosine x, cosine inverse. I don't even know if mine does that. I have a scientific.
Yeah, I have another scientific calculator. Let's see what this calculator does. Do I have cosine? Let me try this. Cosine inverse of negative 0.5. Let's see if this gives me anything better. Cosine inverse negative 0.5. No, it's not.
Oh, it does. It has it.
Yours does it?
Yeah.
Degrees or radians. Depends on if you're degrees. If you're in degrees, it's going to give you 120 degrees. If you're in radians, it gives you that radian value, but it's not going to give you any like the pi that you need. So, and you know, we kind of want the exact answer. So we say that 2 pi over 3 is an exact answer. Your teacher probably wants you to give the exact answer, but 2.0944, that's like an approximation.
Yeah. Yeah, I have no idea. She didn't specify on the guide if she wanted radians.
It should say a exact answer for this question.
Exact. Okay.
Because yeah, this type of question, she probably wants like 2 pi over 3 as the answer. But anyways, I'll show you another example because that's kind of hard. Let me show you sine of x equals root 3 over 2. Watch.
Okay.
Check this out. Sine of x equals root 3 over 2, right?
Yeah.
Is that the question that you're trying to find? Now
Yeah.
check this out. Remember how I told you cosine was like x because it goes left and right?
Yeah.
Sine is like what?
Y.
If cosine is like x, then what is sine like?
Like Y.
Sine's like y. So if I have a circle, then the values that I want are the values on the top. Because
Okay.
why do I want the top? Because sine is what? Positive.
Y.
Huh?
Because sine is Y.
Sine is y, and also, is this number positive or negative?
Positive.
So we're looking for where sine is above the y-axis.
Okay.
Sine is positive.
Yeah.
And where does sine equal root 3 over 2? Well, I forgot, so let me draw a triangle. Look. So I know that this is the pi over 6. It's the smaller degree, smaller angle. This is like the pi over 3. And across from the pi over 6 is 1. This is the hypotenuse is double, it's 2. And this is root 3. So sine is what? What was it again? Sine is like opposite over a hypotenuse, right? Or
Yeah.
so katoa?
Yeah.
So then where is the opposite? Root 3. This one. This one, the opposite is root 3. The opposite is root 3 on pi over 3. The opposite. So a triangle can help you figure out anything. Because you know what I mean?
Yeah. So
or you could memorize the circle of trig. If you don't want to do that triangle way, then just memorize the circle of trig and do something like this. Root 3 over 2 is a bigger number, so I'm gonna go here. Look, I'm gonna go here. I want these two. I want these guys. I want this x.
Yeah.
The skinny x. I want the skinny x instead of the fat x.
Yeah.
I want the tall x. Do you get it? There's a tall x and then there's a short x. That's fat. There's a tall skinny x and then a short fat x. I want the tall x. Why do I want the tall x? Because root 3 over 2 is big. It's a big number, bigger than 1/2, right?
Yeah.
Root 3 over 2 is what? It's a bigger number.
It's probably like 1.5.
Square root 3 divided by 2 is 0.866. And then 1/2 is 0.5. So I want the y value to be bigger. So I want the tall x, not the short x. Do you get that? So then my answers are here, 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 and here. But it has to only be these two. Why? Why is it only those two?
Because you want the positive values.
That's right. That's right. Yeah. And I know how to count by, guess what I'm about to count by? Pi over 3. Because it's the 60-degree angle. It's the bigger angle. So watch how I count. You got to know how to count. Watch. Pi over 1 pi over 3. 2 pi over 3. 3 pi over 3. 4 pi over 3. 5 pi over 3. And 6 pi over 3. Guess how many slices of pizza I have now? Tell me how many slices of pizza do I have? Equal slices of pizza.
7.
1, 2, 1, 2, 3, 4, 5, and 6.
Oh.
Why do I have 6? Multiply the number on the bottom by 2. Sorry, pi over 3. When you count by pi over 3s, there's 6 slices of pizza. If I count by pi over 6s, what's the denominator? 6? What's 6 times 2?
12.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 12 equal slices of pizza. I want to open up a pizza shop called Sokatoa and say you guys can cut your slices of pizza in pi over 3s or pi over 6s. If you do pi over 3s, you get 6 slices. If you do pi over 6, you get 12 slices. If you do pi over 4, you get 8 slices, because 4 times 2 is 8.
Yeah.
If you do pi over 2, you get 4 slices, because 2 times 2 is 4. I don't know if I said that right. My mouth was saying one thing and my brain was thinking something else. I don't even know what I just said.
So good.
So finally, the answer, x equals what?
So, okay, so you got 3 pi over 2. I mean, root 3 over 2.
Mm-hmm.
Sine x equals rad 3 over 2.
Mm-hmm.
Sokatoa. Sine equals opposite over hypotenuse.
Yeah.
So if you create a triangle, and this is your theta right here. Wait. Okay. Oh, yeah. Okay, I remember now. The first thing you have to figure out is, correct me if I'm wrong, you have to figure out, is it a 30, 60, 90 or a 45, 45, 90?
Correct.
Okay.
Correct.
So
exactly. So the type, yeah. There's only 2 cases, 30, 60, 90, and then 40, 45. 45, 45, right?
yeah.
So which one is this?
This one, this is a 30, 60, 90.
Correct. Why is that?
I just remember that in the 30, 60, 90s, the hypotenuse is twice the length of the short side.
Yeah, but there's no triangle given. I drew that triangle. You wouldn't be given a triangle.
Yeah, I'm gonna have a unit circle though.
Okay.
So hold on. Root 3 over 2. Okay. Root 3. Okay. So this is root 3 over 2. I don't know. I'm going by the coordinates. I don't feel like I'm doing that right. Am I supposed to go by the coordinates? Like watch
By looking at the circle of trig? Yeah,
yeah.
I mean, you could memorize that circle of trig. That doesn't hurt. But you got to memorize it though. You can't be looking at it. That's the point. Because you got to get it out. If you're using that, does she allow you to use that on the test?
He does.
Really? Oh, then what you do is you just look at the circle of trig and then find where the y value is root 3 over 2. Just read it off on the thing.
That's it?
Yeah.
So okay, so since this is root 3 over 2 right here.
The y value though. Remember, it's the y value. It's the y coordinate. So where's the y coordinate root 3 over 2?
The y coordinate is root 3 over 2, right?
Yeah, at pi over 3 and 2 pi over 3. At 60 and 120, right? The y value is root 3 over 2.
60. Oh wait, you know what? Let me just try this. Let me see if this works. Sine. Where's the sine at? Sine of root 3. Where's root? What? Sine root 3 root 3. Did you get 1.047?
Hold on. 1 point. Well, no, that's you want the exact answer, not the decimal approximation.
Oh, you mean in radians?
Correct.
Okay.
No, not in radians. I mean the exact answer in terms of pi. Because if you give a decimal answer, that's also in radians. So 1.57 is a radian, and so is pi over 2. Or it's pi over 2 is like 1.57, I think. I don't know. But let's see. But back to this. Where were we? This is day today. Oh, I got logged off. What's the meeting ID again?
Oh, it's
I got it. I got it. 427 272 949. I should invite people to come chill with us. We do math now for fun.
Yep. I can't believe it, man. Yeah, they got me out here doing math. I thought I was.
All right. I was here, I think. No, not here.
It's pi over 3.
Okay, let's see. I had something. Oh, there it is. So, okay, look. Pi over 3, correct. Because if you look at the circle of trig, right here, we're looking for where the, like I said, where the y value is √3/2, right?
Yeah.
Now the sine is like the y value, right? So it's positive on top, and guess what? It's negative on bottom. See this?
Yeah.
So yeah.
Cool.
So you want to try another question like that? I'll let you do one. See if you can get it.
Sure.
By the way, what's the answer? Tell me the answer to this question. Where does sine x equal √3/2? Tell me the answer.
Where does sine x equal √3/2?
Yeah.
I thought it was just pi over 3.
Okay. It is.
It is?
Pi over 3 and what?
Oh, the coordinate, right? Okay.
It's at 2 places. Sine x equals √3/2 at 2 places.
Okay. Oh, okay. At pi over 3.
Yep.
And at 2 pi over 3.
Yep. 2 pi over 3 would be the answer.
So it would be both of those.
Correct. There's 2
Wow.
solutions. If that's only if they say between 0 and 2 pi. That's only if they say that.
Okay.
Then there's 2 solutions. If they don't say that, then there are infinite solutions actually.
Okay.
Because the sine function goes on to infinity. There's some questions where they don't say that you're restricted between 0 and 2 pi. So you have to give all of the solutions, but I don't know if she assigned those.
No.
Okay.
No. Okay.
That's good. Those are tricky.
Cool. Oh, you see on the right where it says graph each function defined as follows over a 2-period interval?
Yeah.
The when it says 2-period interval, is she just saying that when I sketch the graph, my repeated pattern is gonna be 2 pi? Or like period 2?
No, it's not going to be 2 pi. That's not correct. But whatever the period is, it's going to be 2 of those. So like if you have a graph for, look, If you have a graph that it looks like that, that's one period. So I got to
Oh,
do it twice. I got to draw that twice, so I got to do that again.
oh,
Two
got it.
periods.
Okay.
Yeah.
So whatever the period it is, put it twice.
Yeah, draw the graph twice.
Oh, got it. Okay.
Yeah.
Thanks.
Yep.
Yeah. See, I'm very I can't I'm very like I need, man, it's hard, man. It's hard being me, bro.
No, I mean, it's hard being anybody when it comes to learning math.
Cause like she'll say something,
Yeah.
but she often won't give you like she doesn't realize how much that we don't know, you know?
Oh, yeah, yeah, yeah.
So she'll just be saying something casually and you know, she'll just throw stuff out there and she won't really explain it, just thinking that we know it. Like she just started
Dang.
talking about Greek letters the other
Next
day.
time she does that, just say, hey, excuse me, would you ask more questions? Do people ask questions when she's explaining things?
No, not really. I'm like the only one who does it, and apparently, as much as I do it, I'm still not doing it enough.
Do it
And
more. Yeah, keep
oh,
doing it because you got to encourage other students to do it. Because what happens is there's a culture of every class. So
yeah,
if like people if like you're not asking questions and then another person doesn't do it, then pretty much nobody wants to do it. But if you
yeah,
start asking one question, if there's like two or three people in the class that kind of ask a lot of questions, then the
yeah,
culture of the class is one where everybody's like feels free that they can ask a question and it's like a good learning environment. So like
yeah,
people should be asking questions in the class, man. So if you're telling me that she's going fast and you're lost, then you got to do your due diligence to ask questions so that other people can also ask questions, you know?
I gotta work on that though, man. Because I'm not gonna lie, it makes me freak out. Like I start getting mad. I start because the thing is, we have been taught a certain way for 8 weeks, and
Okay.
then the week before the exam, you start doing something completely different. Like
Yeah.
it's like, yo, like I understand we got to learn new stuff, but like you told us this whole time to do it this way, and then you just throwing something else completely different. Like slow down, you know. But
Yeah.
I
You
had to
could
learn.
you can also say, hey, can you slow down a little bit?
Yeah,
Can you write a little bit slower? Sometimes people say that. That's fine.
for sure. Yeah, I had
The-
to learn Greek last. I had to learn some Greek 2 weeks ago, because she was just giving formations and she threw this letter phi out there and she just casually said it. Okay, now we're gonna put phi when she used to put c, and then she
Mm,
started putting phi, and
got
then
it.
it's wait. What is phi? Oh, it's a Greek.
Okay.
Oh yeah, and then wait, stop. What is gamma? Oh, hey, wait. Like you know what I mean?
Yeah. Oh man, that's tough.
Yeah.
Tough. Yeah. So which one do you want to try now?
Um. Okay. Cool. Oh. I think I know radians to degrees. Let me try it and then just let me know if I did it right.
Okay. So like on the top part where it says 135 degrees.
Yeah. I'm gonna do A real quick.
Okay. Let's see. Let's see if
So
I can copy this.
what I remember about this is since it's in degrees, we want it in radians now.
Okay.
So
Yeah.
we're gonna multiply by a conversion factor,
Correct.
and since we want um radians, radians is gonna be in the numerator.
Good. Good, man. You remember. That's awesome. That's right. Whatever you're trying to go to, that should be in the numerator.
Numerator.
Yeah.
Cool. So since 180 um wait 100 okay 1 pi is 180 degrees.
That's right. That's right.
I'm gonna go 135 times 1 over 180.
Times
which
1
is
over 180?
Yeah, 1 over 180.
Why not just do pi over 180?
Oh, yeah. Pi over 180.
Okay.
135 times pi over 180.
Okay, what do you get?
135 pi over 180.
Okay.
And then now we got to reduce that.
Twenty-seven pi.
27 pi over I got 27 pi over 36.
Yep.
And then we can go even more by
Mm-hmm.
putting in there, and we get 9 pi over 4. Wait, no.
I divided everything by 9 because
I know.
I noticed that both of those numbers were divisible by 9.
Okay, here we go. 3 pi over 4.
Yeah.
Okay.
Yeah. It's good. 135.
Mm-hmm.
Yeah, good job. Good job, Justin. Yeah, you multiply. If you're trying to go to radians, then you want to multiply by pi over 180. That's good.
Okay.
The degrees cancel out. Now it's in radians, and this is the exact answer. All right, so that's the exact answer. And
Cool.
so notice that 135 is it's sort of like one of our special angles because it gave us 3 pi over 4. So
Yeah.
that's one of those things. That's one of those angles you kind of want to memorize a little bit.
Yeah.
The angle 135. So if you look at a circle,
Mm-hmm.
shoot, this is an ellipse. All right. So if you look, watch. I want to teach you how to count. Now, what is 135? 135 seems to be maybe a 45-degree angle. Maybe. Let's think about 45-degree angles for a second. That's 45. So you got to be a little bit familiar with the circle of trigs. That's 90. What's this? That's
40.
135, right?
Oh, yeah. Okay.
135.
Hmm.
And what is this?
180. Yeah, 180.
And what's this angle down here?
2,
225.
5. Yeah.
So be a little familiar with these. This is like 270. What's this one? I think it's 315. There's certain angles that this is 0 or 360, right?
Yeah.
So I don't know. Those are the degrees, and you also need to know the radians. But anyways, that's just some other stuff.
Cool.
Yeah,
Okay.
that's converting from degrees to radians.
Well, since you're here, can
Yeah,
we do some logs real quick?
sure. Let's do some logs.
All right. Let me find the logs. Okay. You want me to send a pic of it, or do you just look at the video? But it's these right here. See 46, 50.
Yeah, send me. Can you send me a pic.
And pic. Okay.
If you're on a computer, you can even upload it to the Zoom chat, or you can just text it to me, whatever you want.
Cool. I'll do a text.
All right.
Cool. It should be there in any moment.
Write a comment on my YouTube channel, and you get the free free session. I'm
What
gonna
up?
start giving like giveaways where I give like 1 hour free private tutoring, you know, for the people who put the most like likes on my videos or comments or something like that, you know.
Oh, for sure.
I'm gonna
I'll
start
take
doing it.
up, dog.
I'm gonna give you all these special sessions then if you keep doing it.
I got you,
You're the only one who commented so far.
bro. I'll put like 100 comments on there. Don't you know? Yeah.
Let's see. Let me send it to my iPad. All right, hold on. So copy. Let's see if I can get it in here. Let me do this. And let's see, crop it a little bit. All right, let's see. Okay, I see. Which one do you want? The bottom, 1, 2, 3, those ones on the bottom, or what do you feel like doing?
Let's do just a sec. Oh, okay. 58 and 61.
Okay, 58.
Is that an example of using the change of base formula?
Let's do 58. Yeah, that is.
Oh,
You could do that. You can say that.
okay.
Um,
That's where you got.
not really. Not really change a base formula. No. But
Oh,
this is it depends. I would say no.
okay.
There's various ways to do this one, but no, I would say no, it's not.
Oh, okay.
I mean, you can change the base at the end if you want, but there's different ways to do this question. So how would you do this question? Like, what do you think about it?
I would try, as at this point, just to keep it real, I would try to do what this website did, where they took the ln of both sides. I didn't really, there were some steps I didn't really understand because when it got down to the math, they were like, factor this, put this here, go over, whatever.
Yeah.
But because, I mean, obviously these bases are not the same.
Yeah.
It's
That
kind of like
works.
where you don't really know what you're doing, but you just do what you saw somebody else do.
Yeah.
I would take the ln of both sides, and so that would make it ln of 5 to the x equals ln of 12.
Okay, good. So you do that. Fine. ln of 5 to
Then,
the x equals ln of 12. Good. Now what?
then I would do that power rule and bring the x down, so make it x ln 5
Okay.
equals ln 12.
Good.
Then, since we want x by itself, I would divide by ln 5 on both sides.
Right.
And I would have x equals ln 12 over ln 5. And I'm not sure if she wants a precise answer or just that, but I would just give
both. So this is
both.
the exact answer.
Yeah.
Just say exact and then say approximately and give
Okay.
both answers. Give both answers. If she doesn't ask, give both. Otherwise, read the directions and just be like, all right, ln of 12. Did you get the answer? Give me the decimal approximation.
That would be
Round it to the whatever, hundredths place.
ln of 12. The ln 5. That will be approximately, we usually round to 4 places in this class.
Okay,
So,
4. Good.
yeah.
And
So
what's your answer?
I got 1.54, wait. Hold on. 1, 2, 3, 4. I was gonna say 5439, but there's a 5 back there. So
Yeah.
that would make this a 0. Okay, so then it would be 54100. to the fourth. If I'm going to the fourth.
No, that's wrong. Try again. You're close. Try again.
It's not 1.5400.
No, close. It's 1.5440.
1.54. Oh, yeah. That's right.
Yeah,
Because that
because
is becoming a 4.
yeah, the 3 comes up. Yeah, you're right. The 9 rounds up to a 0, or the 9 rounds up to 10. So you carry the 1 and then you keep the 0. If you carry the 1, 3 plus 1 is 4.
Okay.
So that's the
Cool.
answer. Oops.
So I guess you don't really need change of base formula then for this.
No, you don't.
Oh, good.
That's why I said that's not a change of base formula question.
I'm glad, because that one is hard to remember for some reason. Change of base. I keep trying to get it down lips.
Yeah. Change of base is like log. Well, tell me, what is the change of base? Do you know it?
I
Charlie!
saw.
Say hi to Charlie. Say hi to Charlie.
What up, Charlie? Charlie need to come through.
Charlie!
Charlie need to stop being scared when I pull up. All I try to do is say hi. Charlie go running.
Charlie. All right, so tell me the change of base formula. If you memorize it or no?
No, isn't it like log base A? Log base A equals log base A of B equals
Okay, log base A of B. That's good. That's a good start.
log base
A of B equals what?
equals log base A of X over log base A of like whatever base I want to change it to, right?
So you said log base A of X over what? Log base A of whatever you want to change it to. So you're saying like C or something?
Yeah.
So okay. So that's okay. All right. Well, you didn't change the base because the base is the same. This is base A, this is base A, this is base A. You didn't change the base.
Okay.
The point is you're trying to change the base. So think about that. You see that? You need to change the base. Let's say you want to change the base to base C or gamma or phi. Just kidding. Change the base to C.
To C.
Oh, cutie girl. Yeah, let's say let's see. Let's say you want to change the base to base C. What would you do?
Okay, so it's still log base A of B equals.
So the base is A. The base is A right now, so you got to change it.
Yes. So
what
on the
would you
right,
change it to?
on the right side, I'd put log base C
Good.
of B.
Yep.
Okay. Over log base A of B.
No, you got to go to the same base. You're changing to base C.
Oh, okay. Okay.
So what's the bottom? Remember, you're starting at base A and you're converting to base C. Any other base you want to, most of the time we convert to the natural or the common log, right? So what's the bottom going to be? So most of the time C is 10 or E. That C is going to be going to the natural or common. But, so what's the denominator?
Log base C.
Correct, because we're converting the base to some base, maybe base C.
Yeah. And then of any, like of N or something?
Maybe. Don't you have to keep in mind that you came from some base?
Oh,
A?
Yeah, we started with A.
So what do you think it is down there? Log base C of what?
Of A.
That's right. Now, exactly, good. So like, think about it like this. This thing goes up. Let me do this. This thing goes up. This thing goes down. Right? Notice you got the B and the A. The B went up, the A went down. The thing that you were taking the base of.
Yep.
So you went from base A to base C, and then the B went up and the A went down. But anyways, yeah.
B over log base C of A. Okay, cool. I have a feeling I won't need that today though, because it looks like it's gonna be like 58, 61, and then those. Can we try 61 real quick?
Yeah, let's see, what is it? 61. Copy. Bring that down here. Oops, cut. Wrong one. I pressed the wrong button. Let's try it.
Cool. So, I'm a little more comfortable with the ln, so I'll probably just use the ln's again.
Okay.
I take the ln of both sides.
Whatever
So,
your calculator has. If your calculator has ln on it, go to ln. If your calculator doesn't have ln, don't go to ln. Go to
yeah.
log.
Yeah, it has ln.
All right.
So that would be ln of 3 to the x plus 1 equals ln of 5 to the x.
Yep.
Then I'm going to apply the power rule.
Yep.
And now I have x plus 1 in parentheses.
Good.
ln 3
Yep.
equals x ln 5.
Right.
Cool. All right. Now
Great job. Great job. Now what?
This is where I messed up. X plus 1 ln 3 equals x ln 5.
Okay.
Because I know eventually we want x on one side, right?
Right.
Yeah, we want x on one side. So I guess we could start by dividing both sides by x plus 1.
Yeah. I don't know. You could do that. You could do anything. I don't like that idea because you're gonna have x divided by x plus 1. I don't want x's on top. I don't want a fraction with x on the top and x on the bottom.
Yeah.
I'm trying to solve for x, so you don't want to have a fraction of x's.
Yeah.
You want to have a sum of x's. If you're gonna solve for x, you need a sum of x's, not a fraction of x's. Like
Yeah.
I don't, you know what I mean? I don't want x over x plus 1. I want x, minus x or something. X minus x plus 1 would be better for me because then I could somehow solve for x.
Yeah.
Oh,
Well, how about we can subtract, wait, I don't know. Can we subtract ln 3 on both sides?
maybe. Well, that's gonna violate certain orders of operations. You know what I'm saying?
Yeah,
There's
yeah.
a multiplication here. There's a multiplication there, so you can't subtract ln of 3, right?
Yeah.
Yeah. So you can't violate order of operations.
Because they're being multiplied.
Yeah. If this was x plus 1 minus ln of 3, then, or plus equals x ln of 5, then I could subtract ln of 3, right?
Yeah.
Yeah, so.
Yeah.
Okay.
X plus 1 ln of 3 equals x ln of 5.
Yeah.
So you can't divide by ln of 3.
Correct. Can't do that.
And you can't subtract ln of 3.
Right.
Man, this is tough.
Yeah, well, I mean, there's a parentheses there, right? And the ln of 3 is on the outside of a parenthesis. So what can you do with that ln of 3?
Oh, yeah, you can distribute it.
right? Yep, yep.
Yeah. Oh man, why'd I forget?
Because like this is a tough question. A lot of people forget this because it's a logarithmic question, so people aren't thinking in terms of algebra.
Yeah.
But it's just algebra. You got to think in terms of algebra.
Yeah. Okay. So you have ln of x plus ln of 3.
So you want to say this. You want to say this. If you distribute the ln of 3, right, it multiplies to the x and it multiplies to the 1, right? So what do you get when it multiplies to the x? What do you get?
Oh, you get ln of 3x.
Be careful. If you're gonna write it as ln of 3x, be very careful because the x can't multiply with that 3. That would be a
Oh,
mistake. So in other words, when yeah, you know what I'm saying? Like like x, like
so
ln,
hey,
yeah, yeah. So what would it be instead? What would it be?
it's better to say um it's better to say x ln of 3.
Yeah, x
Okay.
ln of 3 because you don't want to confuse the x being with the 3 because it is not with the 3. Got it? I mean, if you do want to write, you could say ln of 3 parentheses x. Be careful. You know that would be my recommendation if you want to put the ln of 3 first, then do that.
Yeah.
But otherwise, just put the x in the front.
Okay.
So now what?
So we got x ln 3 plus ln 3
Yep. Then what?
equals x ln 5.
Right.
Okay.
But
X ln 3 plus ln 3 equals x ln 5. All right. We
yeah,
want x.
this is a tough
We want
algebraic.
x on one side.
Yeah.
Yeah, yeah, it's a tough one. X ln 3 plus ln 3 equals x ln 5.
By the way, you got
So
five
if we
minutes
want
left.
x,
By the way, if you got 5 minutes left after this, it's $10 a minute. Just kidding, just kidding.
oh, uh, oh, okay.
$10 a minute,
I was
man.
about to overdraft the credit card. Let that write a bad check or something. No, I'm just kidding. Okay, so we want x on one side.
Yeah.
Since we want x on one side, we could either divide by ln 5 on both. Wait, no. Or how about we divide both sides by ln 3.
Okay, maybe. Um, I'll give you a hint if you want, or do you want to think of it on your own? Or did you get disconnected? You got disconnected. You back?
It's trying to load up. Yeah, I'm back.
Okay, cool.
Okay. Can you hear me?
Yeah, yeah, I hear you.
Okay. All right. X ln 3 plus ln 3.
Mm-hmm.
Oh wait. Should we factor out a ln 3?
Yeah, if you did that, you know that you would go back to this. If you factored out a ln of 3, you would actually go backwards, believe it or not.
Yeah,
You see what I'm saying?
that's true. That's true.
So yeah, you don't want
Yeah,
to do
yeah,
that.
we'll be going.
You don't want to factor out the ln of 3.
Okay, got it. X ln 3 plus ln 3 equals x ln 5.
Yeah.
Hmm.
Yeah, it's a tough one, but once you get it once, you'll have it. If you can figure this
Oh,
out, yeah, you gotta just, if you do it once, you'll know it 30%. If you do it twice, you'll know
oh,
it 50%. If you do it 3 times, you'll know it like 85%. You do it 4 times, you'll know it 99%, you know?
I need that 100.
Then you gotta do it 6 times, bro. No. No, they say 7 times. If you repeat something, if you watch something 7 times, then you know it. I heard
Okay,
that. I heard that.
got you. All right. Gotta start with 1 time.
Exactly. One time, one time.
Right. X ln 3 plus ln 3 equals x ln 5.
You made it like 80% of the way, man. You're like
So far?
80% of the way there. Yeah.
Oh, sweet. Okay. Perhaps divide both sides by ln 3 plus ln 3.
Okay, you can't do that. A good idea.
Oh,
Good idea. But that's not going to work in this case because, I mean, first of all, there would need to be, you would need some parentheses here, you know, in order to do that.
yeah.
But they're not there.
Okay.
Yep.
Or how about both sides by ln 5?
Divide both sides by ln 5.
Mm-hmm.
That would work, but there's a better way to do it.
I'm gone, bro. I have no idea. What's the better way?
All right, so I'll tell you, you got to basically get all the x's on the left. So now you got to start thinking algebra. I'll give you a hint. Just think all algebra at this point. What if the question, let me show you something. What if the question was 2x plus 3 equals 5x? Or let's say, let's change this to like, let's do this. Let's say it's, what if the question was 5x plus 3 equals 2x? What would you do?
Oh, I would want to get the x's both on the same side.
So what would you do?
I would either subtract 5x to put a negative 3x on the right,
Okay.
or subtract 2x to make it 3x plus 3 equals 0.
Okay, so subtract 2x, and you get 3x plus 3 equals 0, right? And then what would you do?
Then I would subtract 3 from both sides.
To get 3x equals negative 3. And then what?
And then divide by 3 to
You get
get
x equals negative 1.
Yeah.
Do you realize that the question right here is the same as what I just did?
That's the same?
Yep. Except
Why does
the numbers are different because it looks weird because it's ln of 5 and ln of 3. But on this example, the numbers were 5 and 2, so it was easier for you.
Oh, man. That thing looks mean, man.
It's the logarithms that kind of complicate it. They look weird.
They
They
do
just
look.
look weird. But you gotta, if you knew that you solved that the same way you solved that, then that would kind of be important. You kind of need to know that.
Yeah,
Right?
you do.
So now that
Yeah.
you know that, what would you do?
X ln 3 plus ln 3 equals. Okay, so now we want the x's on one side.
Okay.
So I'm gonna subtract x ln 3 from both sides.
Yeah. Now you're talking.
Got it.
Now you're talking, man. We're in the money now.
So now it's x ln 5 minus x ln 3
On the right hand side?
on the left. I got x ln 5 minus x ln 3.
Wait, did you subtract x ln of 3 from both sides or x ln of 5 from both sides?
Oh, I subtracted x ln of 3 from both sides.
Okay, so then on the left-hand side, then they cancel out. You see? On the left-hand side, these cancel out, don't they? You have
Oh,
x
yeah.
ln.
Yeah, you're right. You're right. My bad.
So then what would you
Because what
get?
it was I was just trying to put the ln's on one side. I mixed myself up.
Okay.
So I'm subtracting x ln 3, subtracting x ln 3. So, all right, let me just leave it like this first. ln 3 equals x ln 5 minus x ln 3.
Okay. All
And
right,
then
good, good.
I just like having the ln's on the left and the other one on the right. So I'm gonna just rewrite it as x
Okay.
ln 5 minus x ln 3 equals ln 3.
All right, that's a good idea.
Okay. X ln 5 minus x ln 3 equals ln 3. All right. Now it's looking familiar.
Good.
Now I can.
Now you're like 85% of the way done.
Oh, sweet.
You're
Okay.
getting there. You're getting there.
Cool. So now I can factor out an x on the
Okay.
left side.
Yay, good job.
There we go.
X times what?
X times ln 5 minus ln 3.
Okay, good.
X times ln 5 minus ln 3 equals ln 3.
Okay.
All right.
Which class are you in? Pre-calc, right?
Pre-calc, yeah.
Okay, okay, cool.
Class is
When
hard.
if I post this, I'm gonna say pre-calc, like pre-calc tutoring session. So people
Yeah,
can
man.
whoever's taking pre-calc, they can watch this.
I'll come out there and put some comments and stuff.
All right, cool.
Yeah. So now we can divide both sides by ln 5 minus ln 3.
That's right. And if you do that, what do you get?
You get x equals ln 3 over ln 5 minus ln 3.
That's right.
Sweet.
Good job. You're pretty much done now. You're pretty much like 100% done. This is like the exact answer. So
Yeah.
this would give you full credit. You're 100% done. So going
Oh,
from number 61, you can say that this is the answer and they would accept that. So
okay.
those are all the steps. So just kind of practice this question again over and over, you know. I'd recommend redoing it. Redo it a
Yeah.
couple times so that you memorize it. Also, one little thing that I wanted to mention was that if you wanted to, you can actually rewrite this as ln of 3 divided by ln of 5/3,
Oh.
which is some teachers don't really care about that, but that's kind of like I saw somebody do that and I thought it was cool.
Oh.
One of my yeah, another teacher that I know, he did that. I was like, oh, that's nice.
Yeah.
Because of the whole subtraction, when you subtract two logs, you can
Mm-hmm.
rewrite it you can condense it to a single logarithm. So hey, maybe that's easier to plug into a calculator. You see what I'm saying?
Yeah. Yeah.
So yeah, that's a property that you should kind of be familiar with. So that's kind of good to do that because you want to understand the properties, you know?
Yeah.
So
Yeah.
you could write it like that, or you can just write it the way it was on the above. Or
Yeah.
you can find the approximate solution too.
Yeah.
So this is exact. And then what about the approximate solution rounded to 4 decimal places? She may want that.
Yeah. Yeah.
So yeah,
Cool.
you can do that too. Which would just be what? Do you want to practice it or you want me to give it to you?
Um, I'll practice it.
All right, so go tell me what it would be.
ln 3 over ln 5 minus ln 3.
What do you get?
Oh, wait, hold on. I typed it in wrong.
Okay.
ln 3.
Did you not use parentheses or something?
I think I put too many parentheses.
Got it. Okay.
3 over ln 5 minus 3. I got 1.5849.
Okay, the answer is 2.1507.
Wow. Okay, I didn't type it in right again. So on the top, I had ln of 3.
Okay.
And on the bottom, I typed in ln of 5 minus 3. But that's not right, huh?
No, that's not right. ln of 5 minus ln of 3 is not ln of 5 minus 3. Yeah, that's not right. You're using the property incorrectly. Because the property says, make sure you're really good with the properties. It says ln of A minus ln of B. What you said was that it equals to ln of A minus B. That's not correct.
Yeah.
ln of A minus ln of B does not equal ln of A minus B. Do you see that?
Yeah.
What you want to say is that it's equal to ln of A over B. That's the property.
Okay. This should probably be the right one now. I
Okay.
got ln of 3 over ln of 5 minus ln of 3. And now
Okay,
I
so
got now I got 2.15066.
that works. There you go.
Okay,
2.1507.
for sure.
That's it. Yep.
Sweet. Thanks, man.
Yes, sir.
How you doing on?
Did we do all the questions, or did you have others?
I got